Hi everyone! Today we're going to talk about how you can find the volume and surface area of a prism. So to start off, prisms are certain types of three-dimensional shapes. There are different types of prisms. Here are some below, but they all share two characteristics, and that is that they have the same two-dimensional shapes for both their bases. So in our examples below, you have your triangular prism here. Let me actually go ahead and scroll down so you can see the name. You have your triangular prism, and for both of its bases, the end faces, you see triangles. There's one here, and there's actually one in the back too. You just can't see it. Square prism has two matching bases, and they are both squares. Rectangular prism, in the front and in the back, there's a rectangle. Same with the pentagonal prism, one in the front, one in the back right there. Hexagonal prism, one in the front, one in the back. Octagonal prism, one octagon in the front, one in the back right there. So they are matching. And then the other characteristic that they share is that for all of the different prisms, they have flat rectangular side faces. So if you look on the sides here, they're all flat and rectangles. And that's because each of the sides of that face is going to create a rectangle. So I kind of like to think about prisms like they're, if you were to take a 2D shape and you were to like pull it out, like stretch it out. So for a triangular prism, it'd be like if you were to take a triangle and you stretched it all the way out so that it was really, really long. Or if you want to think about a stack of Post-it notes. This square prism kind of looks like if you had a stack of Post-it notes, but you put it on its side. So that's the prism family. And just like a family, or just like a person, I guess, prisms have a first name and a last name. The first part of their name is their base shape. And then their last name is the fact that they all belong to the same prism, so that their last name is Prism. So a triangular prism is a prism that has triangles for their faces. Square prism, as another example, is a particular prism that has a square for its face. Now you probably also noticed that these two particular prisms have arrows pointing to them, and that's because they are the most common types of prisms, the triangular prism and the rectangular prism. And from a previous lesson, you learned that the rectangular prism is also sometimes called a cuboid, but most of the time we call it a rectangular prism. Just know that those two are interchangeable. Make sure that this stuff is in your notes. Okay, from your book, a prism is a solid with two parallel polygons for its end faces and a uniform cross section. That's basically saying what we just said. Two parallel polygons. So this is a polygon, closed shape with many sides. Parallel polygons because they exist on two different planes and never touch each other. Those are the end faces, and a uniform cross section. Uniform cross section just means that if you were to cut into it, let's say this piece in the middle here, you would also get the same shape. Uniform, meaning it's the same no matter which way you cut into it. Same with the pentagonal prism. If I were to cut into it, I just get another pentagon. So it's going to be matching. Hexagonal prism, if I cut into it, I get another hexagon inside. Kind of like if you were to cut into a piece of Spam, it would look like the same shape. Each end face is also called a base. And we talked about that earlier. These are all the bases. And a prism is named by the shape of its base as shown below. So we just talked about that. So just introducing you to like the same concept, but maybe different vocabulary. The perpendicular distance now, perpendicular just means that it makes like a 90-degree with the bottom. Perpendicular distance between the two bases is its height. So this right here is the height because it goes up and down. This right here, cutting through and making 90 degrees, would also be the height because it's cutting through up and down, straight line, no slanting. And then the other faces are called the lateral faces. You see that a lot in science, actually. Like if you were to look at a shark's fins, the fins on the sides are called the lateral fins. So that's just a fancy name for the side faces. And then, like they said before, all the lateral faces are rectangles. Cuboid is a rectangular prism. We just talked about that. But let's look at how you would figure out the volume of a cuboid. So we talked last time about how the volume of a cuboid or rectangular prism is the length times width times height, right? Because we're trying to figure out how much can fit inside this entire space. So what we can do now, if we wanted to use this formula to help us figure out the volume of any prism, right? Because this is just the formula to find, or the volume formula for a rectangular prism. So how can that help us figure out the volume of any type of prism, whether it's a square prism or a pentagonal prism or whatever, right? Well, they're related to each other. The cuboid's formula is length times width times height. And basically length times width is the area formula of a rectangle. So you're basically taking the area of a rectangle and multiplying by height. And you can use that formula to translate to any prism's volume. You're taking the area of whatever that base shape is. It's a rectangle here. Find the area of that shape and then just multiply by the height of the entire prism. So that's how we got the volume of any prism to be the base area times the height. Make sure that this goes into your notebook, and then we're going to go over and explain some example prisms and what we mean by base area times height. Okay, so again, this base shape is a rectangle, so base area times height would be area of a rectangle length times width times the height. Let's look at this triangular prism now. So remember the volume of a prism is base area times the height. You'll probably also notice that it's height with a capital H, right? In the past, you've seen height with just a lowercase h. So you'll see that when they mean that when you have different heights, the height with a uppercase h just means the height of the entire prism, because you'll be able to see other heights as well. So let's take a look at this then, so that you can understand what I'm talking about. It says in the figure, it shows a triangular prism in which BC is equal to 10 inches, AN is equal to 7 inches, and CF is equal to 13 inches. Find the volume of the prism. So volume equals the base area times height. This base is a triangle. So we're really figuring out the area of the triangle times the height of the entire prism. Okay, well, the area formula for a triangle is base times height divided by 2. So we're going to figure that out, and then we're going to take that answer and multiply it by the height of the entire prism. So notice here, small h for the triangle's height, big H for the prism's height. So I'm going to put that in the notes here so that you can see that. This is the height of the prism. This is the height of the triangle. Different heights. It's going to be different numbers. Okay, so if we're looking for the base and the height of the triangle, let's do that part first. Well, the base is what's running on the bottom. So that's going to be that 10 right here. This is my base. Okay, so it's going to be 10 inches for my base times the height of just my triangle is going to be this 7. Okay, because we're just looking at the triangle at this point, and that triangle's height is 7 inches. Take those two numbers, multiply them together, divide by 2. That'll be that part of the formula, the area of just the triangle. Now we have to multiply this answer by the height, big H height of the entire prism. Well, this right here is the entire prism. What is the height? You're probably thinking, well, it looks also like 7. No, that's the height of the triangle. When we talk about the height of the prism, we actually want to put this triangular prism upright. It's kind of sideways right now. If we were to put it upright, it would look more like this. Let me see if I can do a good job of drawing that. Okay, it would be upright like this. So then the height would actually be this number right here, this measurement. And that number is 13. The T was just covering that up. That's 13. Okay? So times 13 inches. So again, 7 was the height of the triangle itself. 13 is the height of the prism, big H. Okay, now we multiply. 10 times 7 is 70. 70 divided by 2 is 35. So your answer will be whatever 35 times 13 inches will be. Oh wait, but this was 35 inches squared because it's inch times inch. So now we have 35 inches squared times 13 inches. So 35 times 13, 455. 455 inches times inches, 3 total. So the answer is 455 inches cubed. It's cubed because it's a 3-dimensional shape, and we wanted to figure out the space inside. A 3-dimensional shape, the space inside has a length, a width, and a depth. Okay, so that's the triangular prism's volume. Let's look at this one. This right here, this example says the figure shows a swimming pool with a rectangular surface, ABCD, not drawn to scale, meaning it's going to look weird, like the 23 should actually be way smaller than the 50, so it's not drawn to scale, like it's not precise, this picture. The pool is 50 meters long and 23 meters wide. It has a depth of 1 meter at the shallow end and 2 meters at the deep end, right? Because your pool gets deeper and deeper the further out you go. So that's why there's that slant there, if you can picture it. Like up here would be the water. And then this right here is where all the little kids would hang out. And this right here would be where the people dive off the board. So they want to know what the volume of the pool is. You're going to do the same thing. The volume is the area of the base shape, whatever is being repeated, times the height of the entire prism. Go ahead and pause the video and try it on your own first. Okay, so first off, we need to figure out what the base is, right? What's the shape that's being repeated in the front and the back? Well, it would be this shape right here, which is a trapezoid. Okay, because remember, a trapezoid is going to just have one pair of opposite sides that are parallel to each other, which is these guys. So a trapezoid this one's kind of on its side, but a trapezoid will look kind of like this. This one looks like this when you actually put it upright. Okay, so this is a trapezoid. So we need to figure out the area of this trapezoid and then multiply that answer by the height of the entire prism. Okay, and then this one, just like the one before, is on its side. So our height is going to be one of these numbers on the side here. All right, let me erase some of this stuff so that I can see my numbers. So I have this trapezoid for my base shape. The area of a trapezoid times the height of the entire prism. Well, the area of a trapezoid has two different bases, this long one and the short one. And so the area of a trapezoid is basically the first base plus the second base, divide by 2 because you're trying to figure out their average, times the height. That's the area of a trapezoid. And then remember at the end, we still have to multiply by the height of the entire prism. So let's just start with the trapezoid's two bases. Remember, it's kind of on its side right now, so we're going to need this long base and the short base. First base is 1, and the second base is 2. Take those two, add them together, and multiply or divide by 2 to get their average. And then take that answer and multiply by the height of the trapezoid. Remember, this trapezoid is sideways, so if we were to put it upright, it would be this number right here. That's the height, the trapezoid's height. So it's this, 50. That's the lowercase height of the base shape. So times 50. And then we still have to multiply by the height of the entire prism. So remember, this prism, I hope I can draw this correctly, is sideways right now. But if we were to put it upright, it would be this number right here, which is this 23. So this 23 right here is the big capital H height. Okay, so the 50 is the height of the trapezoid. If you were to, basically turn it over and put it upright. I'll use the green to show you that. So if we were to take this and turn it upright, it would look like this. So then that's why the height would be this number. And then the big height would be the 23 on the side. Kind of have to move it in your brain a little. All right, let's do these calculations then. 1 plus 2 is 3. 3 divided by 2 should be 1.5. That 1.5 times 50 will get us the area of just the trapezoid. Then we still have to take that number and multiply by 23. So then we get 1,725. This is a volume, so it should be meters cubed. That's our volume answer for this problem. So just like before, it doesn't matter what the shape of the base is, you just gotta figure out its area, take that answer, multiply by the height of the entire prism. And that'll just change based on the shape of the face. Okay, now let's talk about surface area. Surface area, as you recall, is the area outside of a prism. Okay, so when we talk about surface area, we need to look at its net because the surface area is made up of all the faces on the outside. So then we need to peel this prism apart and look at all the shapes that make up its kind of shell. So the example here is a pentagonal prism. And this pentagonal prism, when you pull it apart and look at its net, it is of course made up of two pentagons, the one in the front and the one in the back. And then all the rectangles on its outside can then be put together to make one big rectangle. Okay? And then now here's where it gets a little tricky when you think about the dimensions of this rectangle. So I'm going to use some color coding here. The height of the prism is going to be the height of this rectangle. Okay? And then you also have this side, side A of the pentagon. That's going to be one of the, I guess, lengths of your bigger rectangle. And then you have another side, we'll call that side B of the pentagon, and that's also going to be added into the length of this bigger rectangle. So basically all the sides on the pentagon are going to be added up together to create the side of the biggest rectangle, D. And then lastly, we have color I've not chosen yet, E. Okay, so all these different sides of the pentagon are gonna be the added up together to be the side of the biggest rectangle. So that's kind of cool, right? That's once you know that as a shortcut, then you can use that pattern to then not have to draw a net each time and come up with a general formula. So that's how we come up with this formula, right? If we're basically adding up together all the sides of that face's sides to get that length, then what we're really doing is we are figuring out the perimeter, right? Perimeter tells us what all the sides added up are. So that's why this formula has perimeter in it. It involves perimeter. The total surface area of any prism is the perimeter of the base times the height plus 2 times the base area. Okay? So that's what we have here. We have, I'm going to slide it down so you can see both of them at the same time. The perimeter, which was adding up all these sides, right? Adding up all those sides is this length right here. Perimeter of the base, I'll code that in red, times the height. The height is right here. So that's why we multiply by the height, because if you multiply those two together, you'll figure out the area of this entire shape, right? And then all you have left over is basically the two areas of the faces, the bases. And that's why you figure out the area of one of the bases, and then you just times 2 because there's 2 of them. So then that way you cover up all the surface area. So this right here is the most difficult to understand, the perimeter of the base times the height. Okay, so let's do some examples so we can get some practice. Example 7 from the book says, the figure shows a triangular prism in which AB is equal to 5 centimeters, BC is equal to 4 centimeters, and CA is equal to 3 centimeters. The measurement of ACB is 90 degrees. This is important right here. This is not just like some random information. By creating 90 degrees, they're basically saying, hey, this one right here is the height, because by creating a 90 degrees, that means this length over here is going straight up and down. So if you have this number, that's basically how tall that shape is going to be. So this right here is very important to know. That's telling you one of these is the height. Okay, and then they said BE is equal to 2.5 centimeters. They first want you to draw the net of the prism, then find the volume, then find the total surface area. Ooh, so we got all of them as a review. Go ahead and pause the video and see if you can try this one on your own first. Okay, let's first see if you drew the net correctly. Okay, so just like our slide before, we're gonna have all of our rectangles that are going to be together as one long rectangle. So how many rectangles do I have? I have one in the front, two, this one on the side here, and then three. I know there's a lot of lines, so three. The shortcut is however many sides your shape has, like I have a triangle, is how many rectangles there'll be, right? Because each side is going to match up to a rectangle. So a pentagonal prism is going to have 5 rectangles together because a pentagon has 5 sides. Okay, and then we can't forget our 2 triangles, and boom, there's our net. Your net should look something like that. It might look a little different. Maybe you drew one of your triangles in the middle. That's okay, whatever. It'll still work out as long as you have 2 triangles and 3 rectangles. Okay, now part B asks to find the volume of the prism. Let's dig back and see if we can remember the volume formula. Volume formula is area of the base times big H, the height of the entire prism. Okay, so let's see. Well, first off, the base is a triangle. So we need to figure out the area of a triangle and then multiply by the height of the entire prism. Okay, the area of a triangle is base times height divided by 2. So let's go ahead and figure out, well, if I have my triangle, let me just write this up here, base times height divided by 2. That's the area of a triangle. If I have this triangle and it is, I feel like it's on its side right now, right? Because we said one of these is going to be its height, but then it's on its side. So let's go ahead and draw it right side up. So it kind of helps us out a little. So it's going to look like this. So the 4 is over here, the 3 is down here, and then the 5 is on the side. Okay, so then the height would be 4, and then the base would be 3, right? So the base is 3, the height is 4, multiply those together and divide by 2. Okay, that's our base times height divided by 2 for our triangle. And now we need to multiply that answer by the height of the entire prism. Well, this prism is right side up right now, right? Because we want our base to actually be on the bottom, on the base, bottom side. And the triangle is on the bottom side with a triangle up on the top. So it is right side up. So all we have to do is now figure out the height. And this is the height. This is how tall the entire thing is, which is 2.5. So now we are done. We just have to do the calculations. 3 times 4 is 12. 12 divided by 2 is 6. 6 times 2.5 is our answer, 15. 15, this is centimeters. Volume is 3-dimensional, 15 centimeters cubed. That's the volume of the prism. And then now we need to figure out the total surface area. So let me go ahead and just erase this so that we have some space. Let's see if we can remember how to find the total surface area. What was that formula? That formula said that, oops, get my pen, that we had to take all the sides, the perimeter, right? The perimeter of the base shape, because that's going to add up to the actual length of this bigger rectangle. That's that perimeter. Take that and multiply by the height, big H. And then we have to, that will just give us the area of this part right here. Then we have to add it to 2 times the area of the base, which is a triangle in this case. Okay, so let's do that. Perimeter of our base, our triangle, would be 3 plus 4 plus 5 plus 4 plus 5 times my height of the entire prism is 2.5, like we said. Those two need to be multiplied together. I'm going to put like brackets around it, so I know that those two stay together. After I add up the perimeter for my triangle, my base, I'm going to multiply that by my height of the entire prism. And then I have to add it to 2 times the area of my triangle. Area of my triangle is base times height divided by 2. Okay, so my base is 3 and my height was 4. We kind of already did this. I'm just rewriting it. And then divide by 2. Okay, so let's do each piece by itself. 3 plus 4 plus 5. 3 plus 4 plus 5 is 12. Take that 12 and multiply by 2.5. Okay, then you're going to get that answer and add it to whatever this answer is. This is 2 times 3 times 4 divided by 2. Okay, 2 times 3 times 4 divided by 2, which is 12. You could have also seen that there's a times 2 and a divide by 2, and then just cancel those out, and then it's just 3 times 4 at the end, because they were opposites, so they could cancel each other out. Okay, so then you still end up with 12. Okay, not done yet. I have to do 12 times 2.5 in my calculator, which is 30, plus my 12 to get my answer, which is 42. So my answer is 42. This is surface area. Area is only 2 dimensions, so 42 centimeters squared. Lots of formulas, but just remember your general formulas that we've given you, right? So these 2 formulas, the surface area one and then your volume formula, can be used for any type of prism. Base of area times the height of the entire prism, and then the surface area is perimeter of the base times the height of the entire prism plus 2 times the base area. Now, the tricky part is your base also has an area you have to calculate. So that's the tough part there. Okay, let's do one last problem. It says the figure shows a trough shaped like a trapezoidal prism in which AB, okay, we have some stuff equal to each other. AB is equal to CD. Okay, those both are equal to 15 centimeters. BC is equal to 20 centimeters. AD is equal to 30 centimeters. CF, where's CF? CF is equal to 28 centimeters, and the depth of the trough is 14.1 centimeters. And a trough is like what pigs eat out of on a farm, you know, like where their food is. They want to figure out the volume and the surface area. And then at the end, they also want to figure out how much it would cost to make the trough if each centimeter squared is 4 cents. Okay, so let's go ahead and pause the video and try it on your own first. All right, so find the volume of the trough first. Okay, I'm actually going to scooch this down because we don't need that information up there. What we do need is extra space. So the volume formula, if you remember, was the base or area of the base. Let me write it. Area of the base times the height of the entire prism. Okay, and then they already told us that the base is a trapezoid. So if you remember, the area formula for a trapezoid is that you have to add both your bases together. We actually need more room here. Area of a trapezoid, let me draw a little trapezoid, equals the base 1 plus base 2, divide by 2 because you're trying to figure out their average. Take that average and multiply by the height, small h. Okay, so if we look at our trapezoid, it is right here. Our 2 bases are going to be 30 and 20. Okay, so 30 plus 20 divided by 2 will give us the average of the bases times the height. Ooh, what would the height here be? I don't have this number here. This measurement is not there. But it's right here. This is the height of the trapezoid. Height of the trapezoid is 14.1. That was tricky. It's all the way over there. But these two are both going up and down, right? So it's 14.1. Let's figure out this answer, and then that's going to be whatever this number is going to be. Okay, so 30 plus 20 is 50. 50 divided by 2 is the average, which is 25. 25 times 14.1, whoops, 25 times 14.1 is 352.5. 352.5. That right there is the area of the base because it's the area of the trapezoid. The trapezoid is the base. 352.5. We still have to take that answer and multiply by the height of the entire prism. Now again, this prism is sideways, right? Because if these are the bases need to be like a base and be on the bottom. So let's redraw this if you need to visualize it. The height would be this right here, which is the sideways measurement over here. So this right here is the height if you were to put it right side up. So the height is actually, big H is 28. Okay, so this needs to multiply by 28. 352.5 times 28 will give us our volume, which is 9,870. 9,870. This is centimeters cubed because it's volume. Okay, let's move on to B. B is asking for the surface area. So surface area, if you remember, that's the one that has the perimeter, right? Because in order to figure out the length of the biggest rectangle that we're going to make when we look at its net, you're going to need to add up all the sides of the base. All right, surface area. Oops, I erased all my important information. This was the height, small h, right? Height of the trapezoid. And this one was the big H, height of the prism. Height of trap. All right, surface area. Surface area, if you remember, involved perimeter because when we unwrapped all the material, it's going to have, well, in this case, it's 1, 2, 3, 4 rectangles. And then it's going to have a trapezoid on the top and the bottom, or front and the back in this case. And then we're going to have to add up all the area. So if you remember, for surface area of the big rectangle, it is the height of the prism times whatever the perimeter was, right? However, this trough needs a top that's open because the pigs need to eat from it like a bowl. So this top up here is not going to be counted in. It's gone. So we need to subtract this rectangle out, okay? What would the dimension of that one be? That one would be 30 by 28. 30 by 28. The 30 by 28 is gone. So we actually are missing one of the rectangles here because it's open. So we have 15, 20, and 15 that we had to add together. So it's a little different than your normal formula because normally you would just add up all the sides. But since one of the faces is open, it would be not quite the entire perimeter, okay? So when we write down perimeter of this base, this trapezoid, we have to do minus 30, okay? So we're not including 30 in there, okay? And then times the height of the entire prism, plus 2 times the area of the two trapezoid bases. Okay, now let's get to the math. Let's erase this so we have more room. And then let's see, perimeter again. We are not all adding up all of them. We're going to do 15 plus 20 plus 15, not quite all of them, times the height of the prism, which was 28. Put those together in brackets, plus 2 times the area of the base. I wish I didn't erase that answer because I had it before. Area of a trapezoid, if you remember, was base 1 plus base 2 divided by 2 because we're trying to figure out the average, times the height, small h, the height of the trapezoid. Okay, so let's set that up. We have the first base, which is 30, plus the second base, which is 20, divide that by 2, times that by our little h, height of the trapezoid, 14.1. Okay. Now let's do some work in our calculator so we can get closer to the answer. In my calculator, 15 plus 20 plus 15. 15 plus 20 plus 15 is 50. So that's like kind of the perimeter. We got rid of one of the sides. Times 28. Okay, so 1400. Plus whatever all this is, multiplied together. But let's do this part first inside the parentheses. PEMDAS, 30 plus 20 is 50. 50 divided by 2 is 25. So this whole thing should be 25. So in my calculator, I have 2 times 25 times 14.1, and that's 705. 705. Add those two together, because PEMDAS says we got to add at the very end, unless they were in parentheses like before. We get 2,105. And this is centimeters squared. And remember, that's because we cannot add in that top. So it's just the sides that we're accounting for. Okay, we're going on to part C. Part C asks how much the trough would cost to make if it costs 4 cents per centimeter squared. So before I erase that, right, like, do I need this information? Or did I need the volume answer? So are we looking, my question to you before we move on, to solve this problem, are we looking at the volume or surface area when we need to actually make the object? Do we need to figure out how much fits inside the volume, or do we need to figure out the stuff outside? If you said surface area, the stuff outside, you are correct. So we actually want to use this number, right? Because in order to make the trough, the plastic or whatever the material is that they use, or clay, they need to figure out how much material they need for each of the sides, well, except for the top, right? The volume would be like how much food I can fit inside. Okay, so I'm gonna use this 2,105. Okay, 2,105 was our surface area, centimeters squared. If it costs 4 cents for every 1 centimeter squared, how much would be the total? Well, 1 centimeter square costs 4 cents. So 2,105 would be just that times the 4 cents. So let's see how much this trough would cost. 2,105 times 0.04. It costs $84.20. Not bad at all. And again, we needed surface area for it because we need to figure out how much it costs to make each of these sides here, which we calculated with our surface area. volume would be how much food can fit inside.